According to Newton's first law, an object at rest will remain at rest unless acted on by an unbalanced force. An object in motion continues in motion with the same speed and in the same direction unless acted upon by an unbalanced force. This law is often called the law of inertia. Hey there. This penny is in a state of non-motion. When I pull this paper, it'll stay in a state of non-motion. Gotta go. To dislodge the ketchup from the bottom of the bottle, I will thrust downward. The bottle will stop and the ketchup will stay in motion.
Here's Professor Helga with the explanation for the demonstration.
In addition to Joe's demonstration and explanation, during the cup and the penny demonstration, the penny was on top of the paper, which was placed over a cup. Since the penny was in a state of non-motion and the paper did not have enough friction to affect the penny stay in its position. So, when the paper was pulled, the penny fell into the cup underneath. During the ketchup bottle demonstration, the ketchup bottle was shot down with Joe's great force. When Joe suddenly stopped his hands, the bottle stopped, but the ketchup inside continued its motion and fell to the top of the bottle, thus releasing the ketchup from the bottom of the bottle.
Acceleration is produced when a force acts on a mass. The greater the mass, the greater the amount of force needed. You can run at this. Oh! That 10-pound weight requires a little force to accelerate. And this 200-pound kid requires a lot of force to accelerate. It's better to accelerate. There's too much mass. The ball accelerates because it has less mass.
In Newton's second law demonstration, Benetta pushed a light 10-pound weight on top of a skateboard. This was easy compared to pushing Joel on the skateboard. This force required to accelerate a heavier mass was a lot more than what was required to push something with less mass. The second demonstration was similar to the first. The bed frame had a lot of mass and was unable to accelerate it because it did not provide enough force. Well, her favorite ball was really easy to accelerate.
For every action, there's an equal and opposite reaction. As I throw the ball up in the air, gravity is pushing down on it, and that is an opposite reaction. When I punch the camera, the force that is applied to the camera is also applied to my fist. Equal and opposite reaction.
During the shower scene for Newton's third law, Lorenzo tossed up a ping pong ball. Sorry I butchered his name. Lorenzo's, it's okay. Initial action of tossing the ball up was met by an opposite reaction, gravity. Gravity caused the ball to come back down. Then, when Lorenzo pushed the camera, his fist was applying force to move it. The same force was also applied back to his fist. This could cause pain to his fist if the force was too great.